Hey there everyone, in this video tutorial series I'll be discussing some competitive programming hacks for like Bitwise Operator, using Bitwise Operator, how we can make things fast, how we can solve some questions using Bitwise Operator. We can call it like Bitwise masking or Bitwise hacks, anything, bit hacks, anything you can call it. So in this series I'll be discussing these Bitwise operators and how we can do some magical stuff with this Bitwise operator. This is an introduction video, so in this video I'll be discussing some common Bitwise operators such as AND, OR, NOT, left shift, right shift, and Zoar. So let's get started with this. Initially I'll be discussing these operators. In the next few upcoming videos I'll be discussing like some basic questions, and in the further videos I'll be discussing some advanced questions from competitive programming websites such as CodeChef or Spoj. Let's see. So let's get started with these Bitwise operators, and let me open this up. So today's topic is Bitwise operator. Bitwise operator. Let's see first how many Bitwise operators we are going to be discussing. So first is the Bitwise AND, that is the single ampersand sign, and next is Bitwise OR, that is this pipe sign, single pipe, and next is Bitwise Zoar, that is this caret sign, and next is left shift operator, which is this. Another one is right shift operator, which is this one, and the last one we are going to be discussing is the NOT operator or the operator, which is this tilde sign. So let's see how this operator works. So first we will take the table of AND. So I'll draw a table here. Suppose we have to input A, B, and we have a result A and B. So whenever in AND we have like 0 0, we'll get a 0. Whenever we have 0 and 1, we'll get 0. 1 0 will give us a 0, and 1 1 will give us a 1. So if both of the bit are set, then we'll get a 1. Otherwise, in any other case, we'll get a 0. So this is how AND operator works. Now let us look at another operator right here, or this pipe sign, and we have an input A, B, and A or B. So if let's write these test cases: 0 0 0 1 1 0 1 1. So corresponding 0 1 1. So corresponding to this, what we will get is, if there is both the bit are 0, we'll get a 0. If one of the bit is set, we'll get 1, or if both of the bit are set, we'll get a 1. So this is how OR operator works. It is kind of similar to A plus B, that is 0 plus 1, and just this exception that 1 plus 1 in binary is 1. So this is the thing here, and in AND it was kind of a multiplication. 1 into 1, that is 1. 0 into 1, that is 0. So this is how these two operators work. Now next we are going to be looking on Zoar operator. Zoar operator is quite useful in competitive programming, and let's see the test cases: A, B, and the result A, Zoar, B. So this is 0 0 1 0 0 1 and 1 1. So in Zoar, if both of the bit are 0 0, then we'll get an answer 0. If both of the bit are set, that is both of the bit are 1, then we will still get an answer 0. If one of the bit is different, then we will get 1 and 1. So this is how Zoar operator works. Now let us look at some examples of this thing. So if we will do something like A equal to 5 and B equal to 7, and we'll do A and B. So how it works is, what is 5 in binary is 1 0 1, what is 7 in binary is 1 1 1. So we'll AND this. 1 and 1 is 1, and then this will be 1 0 will be a 0, and this will be a 1, so it will become 5. This is how this AND operator works on these numbers. So as the name suggests, bitwise operator. What does the word bitwise means is that it operates only on bits. what do you mean by this is binary representation. Binary representation. So these operator works on these bits. And yeah, let's look at left shift operator now. So the left shift operator, which is this one. So what it does is, suppose we have an example here is 5 left shift 1. So this is how we write this thing, 5 left shift 1. Now what is 5 in binary? So it is 1 0 1, and this is 3 and 5 more, 1 2 3 4 and 5. So this is the representation of 5. This is the representation of 5. Now what if we do it with a left shift 1? So what will happen is, this leftmost bit, just 1, because here it is 1, it will get discarded. We will discard this bit from here, and we will put a 0 at this end. So what this will become is 10 now. Now let's take another example. For example, we can do is 5 left shift, and then we can write 2. What it will do is, this is 5, this was 5, and what we'll do is we'll discard these 2 bits, add 2 0 at the end. So what it will become is 20. And this is how it works. Let's look at the code of this thing. So what we saw in the examples were C out, and 5 we can do left shift 1, and then we can go for a 5 and a left shift of 2. Let's see these answer. Okay, let me run this code. Let's see what we get here. Okay, I'm missing on to something. I think I'm missing on to something. Okay, I haven't saved the code, my bad. Okay, so it will be 10 and 20. So we have seen this example right here. Now let me tell you in brief how this thing can be working. So 5 left shift 1, what we can look at, this is 5 left shift 1 kind of means like 5, and we are multiplying it with 2 to the power 1. And what 5 left shift 2 means here is, we are multiplying it with 5 into 2 to the power 2, which is 20, and which is 10. So what does the left shift operator really means is, we can write a note here, that left shift operator means something like, if we have a number a and we are doing a left shift n times on that, so what does that mean is a into 2 to the power n. So we are doing this multiplication kind of work with power of 2 quite easily here. This is what left shift operator means. So this is an important thing you have to keep in your mind, note it down somewhere, it is very helpful. And next thing, let's see, is a right shift operator. So the right shift operator, let me change the color, right shift operator. So the right shift operator is represented by this sign. This sign represents the right, by this sign, this sign represents the right shift operator. Now let's take an example similar to that, 5 right shift 1. What we'll get here is 5. 5 in binary is this 1. So this is 5. What we'll do right now is, we are going to be discarding this, the rightmost bit. So we are going to be discarding this, discard this bit, and what we are going to do is, we are going to add a 0 at the leftmost position, which is this one. Okay, so this is how things are looking here. So what it will become is, let me do this math, wait, yeah, we can run the code and verify it, because it is 2 here. So let's run this code for right shift. Okay, so yes, we can run this. So it is 2, because in this we can see, I'm sorry for that. Yeah, in this we can see is, this thing left here is, this is 2 power 0 to power 1, that is 2, so it is 2. This is how right shift operator works, and similarly we can have a note here as well, which is quite important. So note here would be that if we are using the right shift operator, that is this. So if there is a number a and we are shifting it right by n bits, so how we can write this: a divided by 2n bits. So this is an important formula which you should remember, or important observation kind of thing which you should remember. So now just one operator is left, which is the note operator. So let's see the note operator, or the this tilde sign, or the complement operator, we can call it complement or complement operator, anything will work. So these are just short names for this note operator. What does the note operator does is it flips the bit, flipping of bit. The main work of this operator is flipping of all the bits. So what does this flipping means here is that flipping here means that we are going to be making all the 0 bits as 1, and we are going to be converting all the 1 bits as 0. So this is what the complement operator means, and we can do like note 5, something like this, which will shift it around. This is how it is done, and yeah, we can run the code and see how it is working. So yeah, okay, so we can be doing something like 5 not, sorry for this, yeah, 5 not. So yeah, it will be -6 because we are going to be shifting all the bits, so it will become negative. Now the next thing we are going to be looking at is a question which comes in mind of many people. So this is that why bitwise. This is the, we can do these things without bitwise as well, so why we are using the bitwise operators? So the number one and the most important reason for this is it is very fast, very fast, as compared to our simple divide or multiplication or the modulo operators. It is very faster than this because let me tell you this, that the division operator and the multiplication operator does all these things in an order of time n square, which is like too much for bigger numbers such as 10 raised to power 6, and in most of the competitive programming questions we get constraints such as 10 raised to power 6, so we cannot go for this division or multiplication directly. We have to do some changes. And the next thing is the modulo operator, which is a very heavy operator. It takes us the time of n cube, order of n cube time. So for 10 raised to power 6 it will be a very large number, so we cannot go for these operators. So what the specialty is about the bitwise operator is that they take a time of order of n time. So for 10 raised to power 6 constraint, we can get this thing done in O of 10 raised to power 6. So we can get things done very quickly in competitive programming. So this was all about this video. It was an introduction video. In the upcoming videos I will be talking about some questions, some basic questions which we can solve by this. So hope you like this video. Do subscribe the channel if you like the video. Thank you.